Hello everyone, I'm Dr. Sri Banerjee, epidemiologist, biostatistician, faculty member, and in this segment I'm going to be going over a poster that I presented and collaborated on, and it was a privilege and an honor to be able to participate and actually present this. Very selective process, but present this in the American Public Health Association 2024. So let's go ahead and get started here. So the title of this is Connection Between Liver Disease and Alzheimer's Disease Mortality. And one thing I wanted to make note of here is that this is quite a bit of a collaboration here. Quite a few universities involved, and students, faculty, alumni are also included. So So my collaborators were Dr. Were Dr. Carol Ewan White, Robin Sadoun, John Hute, Dr. Jagdish Kujandani, and Dr. Rafael Gonzalez Lagos, and then Kelly Keith. This was an enormous undertaking, but we were able to accomplish this. So let me focus on this piece by piece. So let me go into the introduction here and focus on this here, and then we can kind of go through and take a look at the other drawings, other areas. All right. So thinking about dementia, so the two things that we're trying to trying to see if there's a relationship between is liver disease and brain disease. And the way, when I was explaining this to my audience, what I was saying is that actually one of my colleagues came up with this, the gut-brain axis. And that is a very important sort of connection. There's a lot of different examples of this. First of all, there's actually an example of when a child is born, jaundice. So the increased level of bilirubin can actually cause brain damage. Something else that is important to make note of is that when you are some of the neurotransmitters, some of the highest amount, about 90% of or so, are actually produced within the gut. So those are two examples of how the gut and the brain are very strongly connected. Now, what is not known from a model perspective, and really also not known on kind of a logical level, there's some common denominators that play a role. For instance, inflammation is kind of the common denominator between the liver and the brain. So these are all areas that are important to note. Even in hepatitis, if you think about it, there are times when there's jaundice, especially from hepatitis A, when there's the acute phase. And so when that happens, then you have potentially brain damage. So there's multiple ways that this is connected, and that's what I'm trying to show here. And I had multiple conversations. Somebody from the Liver Foundation, actually from India, and comes from there to attend APHA, actually was telling me about some of the common problems such as NASH, non-alcoholic steatohepatitis. So due to the increase in obesity, that's something that has really taken off and increased. So this is actually a timely topic because this is showing the interrelationship there. So let me go ahead and zoom out here. Let's reset zoom here. And then briefly take a look at this figure right here. And then zoom in on here. So I don't necessarily need to zoom in either. So what I was trying to show here is Pennsylvania, because I reside in Pennsylvania, and looking at the two major cities, Philadelphia and Pittsburgh. So if we look at Philadelphia, all of this red is the propensity of having liver disease, and it seems like more of a city sort of phenomenon that is taking place. So this is Philadelphia, and then this over here is Pittsburgh. And so even if you see in Pittsburgh, there's not as much of a preponderance. However, in these areas, in the center, you still see liver cancer. So liver cancer is not necessarily only liver disease, but liver cancer can be indicative of liver disease. So what did we do in this research? So we reset zoom and then kind of hone in on materials and methods. There we go. Okay, so if we see this, what we used is the National Health and Nutrition Examination Survey between the years 1999 and 2010. The age group was 20 years or older, and of course the origin was 1999 to 2010. Of course, the analysis that you can conduct at that point is only cross-sectional. However, when you add linked mortality data, and that's through December 31, 2019, then you're able to kind of conduct a follow-up analysis up to mortality. So one of the causes of mortality, of course, there's overall mortality, but one of the causes identified within the data set, fortunately, is Alzheimer's disease-related dementias. And so the deaths that are pertaining to that, that data is included. And if you want to look at the ICD-10 code, or if you want to look these up, then be my guest. All right. So these are the confounding factors that we included. Age and gender, education, ethnicity, these are a must. And even poverty status. And some of these are mentioned twice. But disease conditions, I mean, cardiovascular disease is absolutely essential. Chronic kidney disease and obesity. So let me zoom out again and then zoom in to some of the findings. Now, this is a model that I include in many of my works. This was something that was introduced quite a few years ago, and I kind of formulated this. So this is the outcome variable, and then this is the explanatory variable. So the idea is that liver disease is predicting, the hypothesis is that liver disease is predicting Alzheimer's disease-related dementias. Now, what am I showing in this area is that what is the death rate from Alzheimer's disease geospatially distributed? Because one of my interests is geospatial analysis. So if you take a look, this is something not very surprising. In the South and some of these areas, there's sprinkling of Alzheimer's disease. But what is important is that in Maine, there's a higher preponderance in certain areas as well. So there's these northern pockets that are kind of not explained in the South. And then if we look at California and Washington has a high mortality rate from Alzheimer's disease, and even certain parts of California. Of course, you see that in LA as well. So now to the model portion of this data set. Let's zoom in here. Let me reset zoom and then zoom in again. All right. So this is an important model. This is the Cox-Hazard regression with confounding variables. So what we did here is included the hazard ratio, 95% confidence interval. Of course, the p-value is indicated through the asterisk. and then we included the hazard ratio of the predictor variables as well to kind of show what is going on. And of course, the reference category here is quite clear, and the way we select that is by looking at what the majority of the population is. So some people a lot of times say that other or Hispanic or non-black or non-Hispanic black, these are the reference, but because the majority of the population is non-Hispanic white, this is considered the reference. Again, when we're looking at education, the reference is high education, and then compared to that, how does lower education make a difference? So there has to be a logical explanation as to how you select the reference category. Where there are only two reference categories, then you're actually having these values are of having the disease condition. And so the hazard ratio here is 1.49. But the main thing, of course, is that people that have liver disease are 2.64 times higher increased likelihood of Alzheimer's disease related mortality than those within the general population. So having liver disease increases the likelihood of ADRD mortality, and then of course compared to people without liver disease. So what does this mean? What are the implications of this? And that is really important. So let me go ahead and reset Zoom, and then kind of hone in on this conclusion portion. Let's do this again and see if we can go in here. All right, so again, we're revisiting this concept of the gut-brain axis. Of course, I already mentioned when you have liver disease, there's 2.6 likelihood of Alzheimer's disease-related mortality. Of course, social and economic factors contribute to liver disease. And then, so basically the idea is that liver dysfunction needs to be monitored and screened in advance. So even though, of course, you have amyloid beta, something that is linking the liver and the brain, but also taking a look at how non-alcoholic steatohepatitis can be screened for in individuals that may have obesity. Screening for this can potentially prevent the development of Alzheimer's disease-related dementias. So that concludes this presentation. There has been a lot of work in this area of liver disease, but something that is important to note is liver disease and some of the conditions, and this was something that was noted by the person that does work in India, that liver disease is something that is not known within the general population, and there actually needs to be more awareness of the types of pathologies and socioeconomic factors that contribute to liver disease, to ADRD. And of course, there's a lot of sociodemographic factors that I can kind of show you here that predetermines Alzheimer's disease before I end this talk. So let's take a look here once more, and these are kind of like findings that are important but really wasn't emphasized. So chronic kidney disease also has a connection with Alzheimer's disease, even when you're looking at, of course, age does, obesity does as well, and that's kind of that's interesting because people that are obese also have higher levels of liver disease. So the main point is that liver disease has been shown to potentially lead to Alzheimer's disease-related dementias, death. But also something else to note is that variables like obesity, variables like chronic kidney disease, all of these are connected and important to make note of and further investigate. So I hope this has made some sense. Thank you for listening.